G'day everyone. Today I'm going to explain local outlier factor. And I really don't like the way that it's explained in general, because it's really simple and it's really confusing for no good reason. So there's three steps. First, you calculate the reachability matrix. Then you calculate the average reachability distance in the neighborhood, and you just happen to take that to the power of -1. All you're doing is finding an average reachability distance in the neighborhood being the n nearest points to a given point. Then you calculate the average reachability, average local reachability density, right? Which is similarly, you're just taking the local reachability density, which we calculated in the previous step, and you're dividing it by the average for that area. So what does that mean? Okay, so you've got some points, right? And each one of these points is close to some other points. And in our first step, local reachability density, we're going to calculate the average of the distance of the reachability distance, which is a special kind of distance, admittedly. But all we're doing is finding the average distance to the points in a given point's neighborhood. The average reachability distance of the points in a given point's neighborhood. And then we take that to -1. So how do we calculate the reachability distance? So reachability distance is really simply the maximum of a distance between x and y. That is, in this example, from 4 to 2. It's our pink line. Or the kth distance, that is the maximum distance in the neighborhood, that is the k nearest neighborhood, of your destination point. So what does that mean? That is, in the case of point 2, we have 2 points in its neighborhood. We have 2 points in its neighborhood. So its neighborhood looks like this. There are 2 points in the neighborhood of k, of 2. 2 points in the neighborhood of 2. And the distances to those points are this distance, which is in pink, and this distance, which is in blue. And what we're going to do to take the reachability distance is take the maximum of the distance between 4 and 2, or the k nearest neighbors of 2, which happens to be 3. So we're going to take the distance between 2 and 3. Now that is the maximum distance, so that is what becomes that distance. So the distance between 4 and 2 becomes equal to the distance between 2 and 3. So 4 to 2 becomes equal to the distance between 2 and 3, which happens to be 0.194. That's how you calculate reachability distance. That's it. Maximum of the distance between point A and B, or the k nearest neighbors of point B. Cool. Another thing to note, you need to keep track of the k nearest neighbors of each point in each row. The reason for this is that later on we're going to calculate some things that depend on the nearest neighborhood. You need to know what those indices are. It's just easier if you highlight it now. Okay, so 1, 2, go across the rows, find those things. Now, procedurally, how do you calculate the reachability distance? Really simple. You go down the columns and you replace the smallest value with the kth smallest value, or the k minus 1 smallest values with the kth smallest value. So in this case, we have going down the column of point 1, so we're saying that we're going from point 2 to point 1, from point 2, so let's do it. So we're going from point 2 to point 1. You need to consider the maximum of the neighborhood of 1, or the distance between 2 and 1. Now in this case, we know that the distance between point 5 and point 1 is a tiny bit bigger than the distance between point 2 and point 1. Okay, so we know that this distance is a little bit bigger. So we just replace it. Ka-chow. That goes in there. That's how you get the reachability matrix. All right, next step. I said before that the local reachability distance is just the average of the reachability distance in the neighborhood, and that's all it is. So for your neighborhood, you're going to take, for point 1, you're going to take the average of these 2 points. It's the average. Simple as power of -1 as well. So it's the average of the distance between point 1 and its 2 nearest neighbors, 0.2 and 0.5. Really scribbled that one up. Average of 0.2 and 0.5. And take that to the power negative 1. That's your reachability distance. You can calculate it all day long. Now, I've got some stuff here to calculate it. And handily, if OneNote feels like collaborating, should calculate it for us. There you go. 42644. Okay? It's the average of the reachability distance along these rows for the two nearest points. Happy days. That's just for the neighborhood. Okay, next step. We need to calculate the ARLRD, the average relative local reachability density. The average relative local reachability density. What does that mean, Ryan? All that is you're dividing your reachability, local reachability density for a given point, say point 2, by the reachability density of the 2 points that are in its neighborhood. That's it. You're just taking the reachability density of this point, local reachability density of this point, and dividing it by those 2 points. The average of those 2 points. The average of those 2 points. Okay? So, let's take this example. So, we're taking point number 2, and we're taking the two nearest neighbors of 2. So we go, that's 0.220 and that is points 3 and 0.4, which are points 3 and 0.4. Take the average of those, we divide the LRD of that point by that average, and you get a comparison of your point to the average in its neighborhood, and it is greater than that value. That is the ARLRD, the average relative local reachability density. Then guess what? To find LOF, it's just 1 on all that. Ready? Done. That's your value. That's how you do it.